Welcome to Scanner School session 162. This is our 2021 Crash Course, Part 3. Today's podcast is sponsored by our brand new training course, The Ultimate Beginner's Guide to Software-Defined Radios. Everything to know to get started with SDR in an afternoon. Our simple step-by-step course will show you how to set up a brand new SDR, install the drivers on your computer, and have you listening to local stations in just a few hours. This free course is available at courses.scannerschool.com. And also by our upcoming free webinar, the 2021 Crash Course, How to Get Started or Up to Speed on Scanning for the year 2021. This free webinar will be held at 8 p.m. Eastern U.S. time on January 26. You can register right now at scannerschool.com/2021. All notes from today's podcast can be found on our website at scannerschool.com/session 162. Before we start this week's podcast, I'd like to take a moment to thank our Patreon supporters. Patreon is a month-to-month sponsorship platform. We have 3 different support tiers, each with different benefits. But the most valuable tier is our $5 a month tier. This equates to sponsoring the podcast for about $1 per episode. Now, not only do our $5 Patreon supporters receive the podcast early, but they also receive a commercial-free version of the podcast delivered directly to their podcast player. Some may say that the included Squelchy sticker pack that is mailed to your home is the best benefit of the $5 level, but I think it's the community or the club that is growing at this level. You see, we meet once a month on Zoom and we have a roundtable discussion about scanning, ask questions, offer advice. Some of the members are answering other people's questions, and we just talk with our fellow Scanner School classmates. This is an exclusive group for our $5 Patreon members. Now, again, if all this wasn't enough at that level, you'll also receive discounts to upcoming Scanner School courses and offerings. Now, you can help support Scanner School by going to www.scannerschool.com/Patreon or www.scannerschool.com/support. Now, I'd like to thank all of our Patreon supporters at all levels, and they are Brian King, Buzz Gold, Chris Paris, Craig Harper, Dan, Ed Walsh, Eddie K, Glenn Bryden, Guy Lee, James Felling, James Peruta, Jeff Block, Jenny Taylor, Jim Heinrich, John Goldenberg, Ken Newberry, Kenneth Fowler, Kevin Zwicky, Lenny Bauer, Les Stevenson, Mark Beebe, Michael Kroger, Paul Teal, Raymond Hill, Richard Armstrong, Robert Kastner, Ronnie Bach, Sal Marandola, Tim Mazza, Todd Glendy, and William R. Can. Now let's start the podcast.
Welcome to the Scanner School, a podcast dedicated to the scanner radio hobby. Class is about to begin. Here is your host, Phil Lichtenberger.
Welcome to Scanner School. This podcast is here to teach you everything to know about the scanner radio hobby. My name is Phil Lichtenberger, and my amateur radio call sign is W2LIE. Now, again, today's podcast is sponsored by our Patreon supporters. I want to thank you all for your continued support, and also by East Coast Pagers, your emergency alerting specialist, eastcoastpagers.com. So if this is your first week joining us for class or your weekly listener, welcome to this week's podcast. Make sure you click that subscribe button so you don't miss out on next week's podcast. Today is part 3 of 3 on our 2021 Crash Course. This will be a little quicker than the last 2 weeks, but again, this wraps everything up as we're going to talk tonight about our first webinar. So hopefully you guys have subscribed to that as well. So if you're new to scanning, returning after hiatus, or just need to brush up, that's why these sessions are here. So again, make sure you register scannerschool.com/session 2021. So let's talk about the hardware. Let's start at the top down because it's just easier for me to think about it that way. So your antenna, right? Your antenna is basically the last thing that you own before the RF comes into everything you bought, right? It's the last stop. It's yours versus the environment, okay? If your antenna is not a good match for what it is you're trying to monitor, then everything else that's between your antenna and radio does not matter. It doesn't mean a thing because if you can't receive on your antenna, it's all for nothing. Antennas need to be matched or resonant on the frequency or frequencies that you would like to monitor. So what do we mean by that? Remember in session 1, we talked about hertz and frequencies. Or actually, I should say this way. Remember in part 1 of this crash course, I think we talked about frequencies and hertz in actually session 2 of the actual podcast episode. But frequencies in hertz, we talked about that just 2 weeks ago. Remember how I said some frequencies we can feel, they're like a vibration. Well, in the RF world, our antennas will become resonant or vibrate, per se, on the frequencies that it is tuned for. This is why we see so many different types of antennas out there and at many different lengths, right? Because antennas are built, they're engineered to work specifically on certain frequencies or ranges of frequencies. So, the lower the frequency, the larger the wavelength. This means that a larger antenna is required for the longer wavelengths. Now, the higher in frequency you go, the shorter the wavelength, and thus the shorter the antenna becomes. So let's think about things for a little bit here. Remember the old cordless phones that were out decades ago? Where you'd have to pull the telescoping antenna out of them in order to use them and get some decent range with them? Those phones operated on or about 47 megahertz. Later, we then had phones that operated in the neighborhood of, say, 900 megahertz, and they had smaller, stubbier antennas. Well, look at your cell phone, right? Where's the antenna on your cell phone? Well, now they're internal, right? And there's multiple antennas in there. You got Bluetooth, Wi-Fi. Every single band basically has an antenna. Somewhere on your phone, there's an antenna all over the place, right? So, as the frequency goes up, right, the antennas get smaller. You can hide them better as well. So, what's the point here? The point is, if you have an antenna that's tuned for frequency A, but you want to receive frequency B, and your antenna isn't resonant on that frequency B, you're going to have a hard time listening to frequency B. Now, some antennas are built and engineered so you can cover a wider bandwidth, or even multiple bandwidths over certain sets of frequencies. One of the antennas that we're most familiar with, and we see most often in the scanner radio world, is a disc cone antenna. Disc cone antennas are what I like to call an equal opportunity offender, right? It's an antenna that works okay across pretty much every single band that we would like to receive in, right? There's no special sweet spot, or it doesn't work particularly gangbusters all over the place, okay? It works equally almost everywhere. There's no gain, though, in a disc cone antenna, okay? And that's why I say it's an equal opportunity offender. There's no sweet spot in it for internal gain. But once you start engineering antennas with gain, you're starting to focus more on their resonant frequency, and it brings in those values, right? So if you want to listen to just UHF, then you could buy just a UHF antenna, and that antenna would have internal gain. It would work really well in the UHF spectrum, but it would work pretty poorly, possibly, on other frequencies. An example of an antenna like this would be a dipole antenna. Okay, you could have dipole antennas that are dual or triple band. They could have filters in there or loading coils that will help the antenna operate over multiple different frequencies. Even the Austin Ferret scanner antenna kind of works that way as well. But again, let's get back on the topic here. If we had a CB antenna, which here in the United States is 27 megahertz, do you think that antenna would work on a system for 800 megahertz? Most likely it will not work at all, and vice versa. You're not going to pick up much at all of CB on a couple inch 800 megahertz antenna, whereas CB requires an antenna that's pretty long, like pretty big. So again, resonant frequency is very important when it comes to the antennas that you're using. Again, like I said, if your antenna isn't worth it or your antenna is shot, then it doesn't matter what you've got hooked up between that and your radio. It's just toast. So disc cone antennas are also favorable because they're omnidirectional, which means they receive in a 360-degree pattern, right, all around it. They're also vertically polarized, which is important here. We talked about polarization in the past, but polarization is the angle or the takeoff angle of the signal, right? It goes up and down. It's vertical. This is also very important when it comes to two-way radios because it's very easy to design antennas vertically because think about it. They go on towers, they go on building tops, and most importantly, they go on vehicles. And what's important too about a vertically polarized antenna that we mount on a piece of sheet metal on our vehicle is the fact that the sheet metal acts like a mirror and creates then a virtual second half of the antenna. Again, ground planes here. So, vertical antenna is important. Resonant frequency, the type of antenna, right? And speaking of types of antennas, we have another special antenna, a Yagi antenna. We talked about Yagis before also. Yagi antennas are phenomenal. They're directional antennas though, right? A Yagi antenna is high gain directional antennas that work over a small bandwidth. So basically, you would need to buy a Yagi antenna in the range of frequencies that you're going to use it on. Say, for example, they'll come in like 840 to 860 megahertz, right? And that's their sweet spot, and that's really all they're tuned to work in. Yagis have very few required parts in order to get them to work. A boom, which is the horizontal structure that things are mounted to, basically. You have a reflector element and a driven element. The reflector element is slightly larger and just out of tune from the resonant frequency. The reflector drives the RF in the opposite direction. The driven element is the element that is tuned or resonant to the frequency you want to use it on. This is where you connect your coax cable. Now, you can have elements in front of the driven element, and these are called director elements. The more director elements you have on a Yagi, the longer the boom you need because you've got more elements, but also the more gain you gain. But as you gain more gain, you then limit the number of usable frequencies it works on, and you also tighten up the beam pattern of the Yagi, or you make it more directional, which is also cool because you also then reject more off the sides and the back of the Yagi. The spacing of the elements is determined by the frequency that you are tuning it for. So typically, you're going to buy a Yagi antenna, and it's going to tell you what frequencies it works for. You could build your own Yagis, but sometimes it's just as easy to buy one pre-made, especially when you have some of these calculations in play. Okay, next in line, we've got coax. If you've got a great antenna, perfect, right? But what happens if you can't deliver that information being captured by your great antenna and delivering it to your radio? This is why we need good quality coax. Now, if you listen to the podcast in the past, you know how I preach about LMR 400 whenever possible. But do you know why? Well, coax has internal resistance in it. All coax does by nature. It just all depends on what frequencies you are monitoring or using it on, and how well that coax allows those frequencies, so to speak, to slide through. Okay? But here's the trick we have to remember. As your frequency increases, the amount of loss in the coax cable will also increase. So you could use, say, 9913 or 213 coax with any issues on HF, or maybe even down to VHF. But once you start climbing to 400 megahertz or 800 megahertz, the effectiveness of that coax can start to suffer. So, for example, let's compare losses at 100 feet here for a couple of different pieces of coax. So RG213 at 46 megahertz is about 74% efficient. At 160, it's 56% efficient. At 450, it's 35% efficient. At 850, it's 22.8% efficient. RG58 at 46 megahertz is 49% efficient. So it's already not as good as RG213. But let's just jump right to 850 here. RG58 at 850 megahertz is only 4% efficient. You've got a 14 dB loss. That's insane. LMR 400, on the other hand, is 82% efficient on 46 megahertz, 53% efficient on 450 megahertz, and 41% efficient on 850. And this is also why we try and keep our coax runs as short as possible, as well as using the right cable for the job. All right, so let's talk about combining and splitting antennas. This is a very common question that I see very, very often. How do you combine all of your scanners into a single antenna? Well, there's several ways you could do so. And while I always don't agree with them, that doesn't mean I also don't practice them or have practiced them. Hint, hint. So the simplest way is with just T connectors or Y cables. Right? You can simply put a BNC T connector on your scanners and just run jumpers between them all. This really isn't a best practice at all because you can actually change the impedance level of the coax cable. But you can also have the radios talk to each other, so to speak. Whereas one may desensitize another, or you may receive a frequency that you don't intend to receive because the other scanner is receiving something different. So it's really not a good way to get things done. I mean, do I do it with my SDRs? As long as I don't see an issue with what I'm trying to receive on it, yeah. But if I need something cleaner, then yeah, I'm not gonna do that with my $30 SDR. What's another way you could do it? Cable TV splitters. Cable TV splitters. Well, now you're gonna drop down to an F connector, and you're going to then lose 3 to 6, maybe even 12 dB per port when you come out the other side of that. So that may not be a good solution either. The right way of doing it is with a multi-coupler. Now, multi-couplers give you a true 50 ohm output on each port, and they're isolated, which means that the scanner doesn't see any other radio on any other port on the multi-coupler. It basically looks like the scanner is connected directly to the antenna. Now, a passive multi-coupler will have loss, but an active multi-coupler will give you or regain that loss and maybe give you a little bit more of gain in there in a preamp as well. I recommend active multi-couplers. It's what I use here. Now, one last trick you could do on the hardware side is filters. Sometimes you've got a frequency or something nearby, a transmitter that is just wiping out, desensitizing your scanner radio. If you're too close to, say, an FM broadcast transmitter, it could wipe out VHF Marine for you, or it could wipe out aviation. I know when I had VHF paging too close to a received side of mine, I couldn't receive anything in the Marine band because the paging signal would come all the time. I had to put a paging filter on. Okay, it would knock out those frequencies. The other thing that could happen too is that if you're too close to a cell tower, it could wipe out 800, 700 megahertz trunking. And the reason for this is because the signal coming into your scanner in that frequency band is so hot, it raises the noise floor. What that ends up doing then is creating so much noise on the scanner's input that it can't actually see the frequencies that you want to receive because they're below the noise floor. I had a coworker of mine that had to build a filter for cellular because where he was staying, there was a cell site across the street. And once he notched out the cell site or the frequencies from the cell site, he was then able to pick up the trunk system for the county away from him because his scanner was then, or the filter was rejecting those frequencies. The scanner was then able to drop the noise floor and return to normal stability usage. So these are some tricks that you can do in order to improve your reception. So on the other side of this break, though, we've got some troubleshooting tips and some other tips and tricks you're going to want to know about. So stay tuned. We'll be right back. Did you know there are ways to help support the Scanner School podcast that doesn't take any time or any extra money on your part? If you go to scannerschool.com/support, you will find we have several ways that you can continue to do your online shopping and help support us. We have links to Amazon. If you click on our link before you go to Amazon, anything you buy from there will help support Scanner School. Now, if you're in the market for a brand new scanner, an antenna, other accessories, we have links to Scanner Master, where you can not only purchase a scanner and accessories, but you can also get your radio programmed. And by clicking on our link before you buy, you are helping to support the podcast. Now, if you're in the market for software, we have links to Butel. And if you want something new to you, we also have links to eBay. Again, just go to scannerschool.com/support before you make your purchases, and you are helping to support Scanner School at no additional cost to you. This session of Scanner School is sponsored by East Coast Pagers. Now, East Coast Pagers is one of my online companies, and we are a Unication, Apollo, and Swiss phone dealers serving the North American market. Now, if you're looking for a personal use pager or one for your department, we can get you a quote at the very best prices. So why does a company like East Coast Pagers support Scanner School? I think that every scanner radio user should at least put one pager in their collection of radios. The reason why is very simple. It frees up your scanner to just do scanning, and then you have one radio that's dedicated to your local fire activity. Now, with a pager, you can have voice storage. You can do tone outs. You can keep it silent. You can go back the next day and listen to what you've missed overnight. It's more than you can do with an out-of-the-box scanner. And with today's pagers having multiple frequencies and even having multiple channels in a scan list, like the Unication G1 can do 8 channels in a scan list. It has 64 memory channels, and out of the box, it comes with 11 minutes of stored voice and a desktop charger. The G2s to G5s, they do P25 Phase 1 and Phase 2 in simulcast environments with stored voice, paging on conventional NP25. Oh, and they're upgradable too to DMR Type 1 and Type 2. They are more rugged than today's consumer-based scanners. And with a pager like a Swiss Phone S Quad, you won't even realize you're wearing one. It'll help keep you informed as to what's going on in your neighborhood. So again, eastcoastpagers.com or contact me directly, Phil at eastcoastpagers.com. Do you have a new scanner? You're having problems understanding how it works? Maybe you're new to the entire Home Patrol database of programming and you can't figure out Sentinel. Did you get a new SDR and you're trying to figure out how to install it? Or you want to learn how to use Unitrunker, DSD Plus, maybe set up a PieAware, or even just make some changes and you don't understand how the system and the equipment works? The podcast might be great for you, but maybe you need a little bit more of one-on-one help with setting something up. I'm available to do just that with you with our private tutoring sessions. You can book me online by going to scannerschool.com/consulting for a 1-hour session. And it's great because we can actually share computer screens remotely, and I can guide you through step by step as if I was sitting right next to you. So again, book me for an hour at scannerschool.com/consulting for your scanner radio one-on-one tutoring session. National Communications Magazine is your personal library of scanner, CB, GMRS, FRS, MURS, and two-way radio articles written by the best minds in the business over the past 3 decades. Your NatCom personal online access account allows you to download the newest issues of America's Hobby Radio magazine, as well as back issues too. So visit natcommag.com to download your free sample issues and sign up today. That's natcommag.com for National Communications Magazine. Okay, what do we do to troubleshoot our scanner when it does not receive? Well, the first thing we want to do here is just make sure we've got our coax cable plugged in. I mean, I've had customers who have called me up and said, hey, my scanner's not working right now. I can't pick anything up. I don't understand what's going on here. And we go through basic troubleshooting, and one of the first things I say, hey, can you check your coax? And they go, oh, yeah, it's in. Don't worry about it. And I said, well, can you double check it for me? And they go, no, I'm looking at it. It's in. I said, well, can you turn it? Will it click into place? Oh, it wasn't seated down all the way, and now the page, now the scanner's working. Well, yeah, that's what happens. So double check your coax line. That's, and again, in every step of your setup, right? The top of the radio to any splitters or multi-couplers or anything else like that too, right? If you've got a lightning arrestor, check your lightning arrestor, make sure that it didn't blow the plug in there, and then go outside. Make sure your antenna is still on the roof of your house. I've had issues where I've had somebody call me up and their antenna had disintegrated on the top of their commercial building. So again, we used a lightweight antenna up there, and it lasted for many, 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 many years. And we had a storm rolling through here, and it wasn't too long after that they called me up and says, yeah, the scanners aren't working. And all that was left up there was the mast. So yeah, we replaced the antenna and they were back in the business again. But still, I mean, check both ends of your coax and make sure that it's all connected and down there and tight. Now, if it is down there and tight on both ends, well, let's double check everything too, right? Put something in that you can receive, like the NOAA weather radio. See if you can pick up an amateur radio repeater, right? Because amateur repeaters are pretty busy. Check a second scanner, right? Plug a second scanner in if you have one like that. This will help you eliminate whether or not it's your setup or if it's your scanner. And again, if you can receive something on the second scanner, then something is wrong with the first scanner. If you can't receive anything on both scanners, then you can continue to troubleshoot your setup, right? Again, if it's just a one scanner, look at the one scanner, make sure that things aren't locked out, like you didn't accidentally lock out the control channel of a trunk system. Or maybe you didn't turn off that bank, or maybe you turned on the global attenuator, right? Things like that happen. Check your squelch. Maybe your volume is just low. That happens too sometimes, believe it or not. So, again, what happens if both scanners don't pick anything up? Well, double check your programming, right? Did a frequency all of a sudden put in a new PL or DPL code? Did they change frequencies? Did a control channel change, right? Do some homework and find out. Go on Radio Reference and see if something has changed in your area. But again, if you can see if other things are being picked up by your scanner, again, like I said, check out a weather radio or something like that, then you'll know if it's your radio, your programming, or if it's everything in general, okay? That's kind of how that would look as well. Again, double checking your coax, even put your hand on it and follow it either through your house or outside, because sometimes rodents will shoot through the rubber jackets and things like that happen. I've had coax lines that have gotten water in them. Not proud to say, but that happens, right? Things go bad. And if you can put your hand on the coax line and follow it around, you may find out just where things may not be working. Again, check all your fittings usually in the spring or the fall and everything else like that is really good practice just to make sure that you don't have an issue down the road and you'll have to sit there and shoot through all things. Again, if you've got splitters or preamps or something like that, make sure all your preamps are powered up, that they didn't short out or something like that. Again, make sure that all of your jumpers are connected and stuff like that as well. That's always one of the very simple and quick things that you can troubleshoot when it comes to your scanners not receiving. Now, if they don't power up, make sure that they're plugged in. Make sure you got fresh batteries. If you've got a power supply, make sure that is on and delivering voltage. Sometimes it could just be the bad wall wart, right? That went bad and it blew. Or sometimes it's an internal fuse and things like that. They do go bad, unfortunately. So these are all things you could check out before things go into repair. Okay, so finally, how do you pick a scanner this year, right? 2020. Everybody's like, encryption is killing the hobby. I don't know. I beg to differ, right? Because again, I've said the secrets are in the searches, and I'm going to stick with that, right? That is my mantra, and that's where things are, right? There's always going to be something you can listen to on a scanner radio. Just because maybe what you want to listen to is gone doesn't mean that the whole hobby is dead, right? Just because your favorite TV show went off the air, does that mean that there's nothing left to watch on TV? We have to get rid of our TVs? Or when your favorite magazine went out of print, does that mean that we can no longer buy magazines? We have to learn to forget how to read? Learn to forget how to read, yeah. Right? No. We find other TV shows to watch. We find other magazines or other books or, right, other bands. When your favorite band stops and breaks up for some reason, does that mean music is dead too? No, right? You could still, right, listen to other music. There's other things out there to listen to besides your local PD or your local fire, right? Just because things go encrypt does not mean that it's the end of the world as you know it. Right? We can still feel fine, to quote REM. So, how do we pick a scanner for our neighborhood, our local area? Okay. I'm going to have a good flow chart as a download with the 2021 crash course that I'm holding again. So make sure you sign up at scannerschool.com/2021 and you'll get the link to download this flow chart to help you out here. So, quick and dirty, because it's going to be kind of difficult for me to explain this one via a podcast medium. It's be a lot easier when it comes to a flow chart and some visuals that go along with this. But here's the gist of things, right? You want to go to radioreference.com and click on the database. All right, it's always the first thing I do. And then go to your state, your country, right? Your territory, your province. Go to your county, your jurisdiction, whatever it is, right? That wherever you live, whatever the naming convention is, that's where you want to go to. And again, look at, I'm just going to talk from the United States, right? So you look at the national level for the national frequencies, like railroads, aviation, right? Look at the state levels for what you want to listen to. State PD, for example. Then look at the countywide level. So let's break this down. Let's just say I live in any town, USA, okay? So I am going to open up Radio References database page, navigate to where I live, okay? And I'm going to look for any town PD in my county's listing. If I see conventional frequencies there, then I know, okay, good. I'm off to a good start here. I may just need a conventional radio. Well, let's take a look. Assuming it's VHF or UHF, right? We're good to go here. And the transmitter modulation type is a variation of FM, typically now NFM. A basic analog scanner would work just fine. However, you may not see FM here. You may see P25, DMR, and XDN. Well, if you see one of those three, you'll need a digital capable scanner in order to receive that frequency. One thing also to note is if you see a capital E as part of the designator, that means that full-time encryption is in play here. And when full-time encryption is in play, it means it doesn't really matter what scanner you get because you're not going to be able to monitor it because you have encryption. Now, if it's got a lowercase e, that means it might be encrypted. So it's not a full-time thing. They could turn it on when they have something sensitive to say, and then they turn it off again. But you don't know, right? Unless you can find out from either monitoring it or finding out from your reference if it's something you can monitor, if encryption is on most of the time or off most of the time. So let's dig down this rabbit hole as well. So we're in Anytown, right? We're looking for what Anytown PD is using. And sometimes we'll see a block above the frequencies. It says Anytown PD uses talk groups on this trunk system. And it may have a link to a trunk system. So we'll go ahead and we'll click on that trunk system and see. Now, if it says EDAX, a Motorola Type 2 or LTR standard, then an analog type of trunking scanner, typically a trunk type or type 3, because that's EDAX, Motorola, and LTR, would work fine as long as the Motorola system isn't rebanded. Now, if it's rebanded, you would need a scanner that supports rebanding. So all scanners in the last, decade or so, I think, support rebanding if they are a trunk tracker type 3 scanner or higher. So when you look at the talk groups on these 3 types of systems, you'll see that the talk groups have a type of A or D in the mode. Okay, A is analog, means again, any trunk type or type 3 would work fine, it's analog. But if you see D, especially if it's an EDAX system, you'll need a Pro Voice upgrade. And if it's D and it's Motorola Type 2, you would need a P25 capable scanner to receive those digital talk groups. Even though it's a Type 2 system, the digital on it is using P25. Okay, what happens though if the trunk systems are P25? Well, again, we want to look at the mode on the talk groups. A D basically means it is digital, and it's a phase 1 talk group. T, as in Tom, means that it's a TDMA talk group, and those are phase 2 talk groups. Now, just because Radio Reference says the trunk system is a P25 phase 2 system doesn't mean you need a phase 2 scanner. It just means that the trunk system is broadcasting out that is capable of providing phase 2 talk groups. The local P25 system in my county is in Radio Reference as a phase 2 capable P25 system, but all the talk groups on there are phase 1 talk groups. Again, if you see DE or TE, it could be encrypted. Again, capital E is full-time encryption, lowercase e is part-time. So watch for that E designator on there. Now again, if you see that the system is DMR or NXDN, you'll need a scanner that supports those as well. Okay, and one last thing to look out for when you're looking at trunk systems is the word simulcast. So if you got a P25 system, you'll see you have multiple sites or one site, right? These sites may just have a name on it, like Anytown USA, end of story, right? Good to go. But if it says Anytown simulcast, that will mean that there are multiple transmitter locations that make up a whole simulcast network. If you can isolate to just one transmitter location, you may not have to worry about simulcast. It may work just fine for you. That means go to town with any scanner radio that you have that's P25. However, if you have problems with simulcast, you may need to get an SDS 100, SDS 200. Unfortunately, the only way to really know this is if your scanner is constantly deaf or you feel like you're missing most of the conversations. I just got feedback from somebody today who just bought a Unication G5 pager for me because, again, I am a Unication dealer. And he's like, you know what? You don't know what you don't know until you know that you don't know it. Basically, he had his G5 turned on for the first time, and he was amazed as to how much it was picking up when he compared it to his TRX-1, which wasn't picking up nearly anything. In his words, he said that the TRX-1 was picking up about 5% of what his G5 was picking up. So that's a huge difference. So what's another workaround? SDRs, software-defined radios. Now, I'm not going to talk about SDRs today because I'm going to table that because I want you to sign up for our free course at courses.scannerschool.com and take a look at our SDR training course. It's a free course. But we're also going to spend a couple of weeks next month talking about software-defined radios. And I've got a very special guest joining us as well to talk about SDRs. I love SDRs. There's so much you can do with them. And I feel like you've got to have one of these things in your scanner radio Swiss Army kit. And we're going to explain all that coming up. All right. But listen, breathe, decompress. We went through a lot over the last 3 weeks, right? We didn't go through everything. That's why we have 160 plus podcast episodes for you to go back on, right? I can't compress 160 podcast episodes into 3 episodes, right? We took just a skim off the top of a lot of these just so that it would be a crash course to get you back into scanning so you would understand what some of the terminologies were, right? If you're brand new to the hobby, welcome, you've graduated, okay? You should understand now what's going on here. If you don't, I am available. Next week is an Ask Scanner School session. You can ask your questions. I will answer them here on the podcast for you. You can join us on the first Tuesday of every month on YouTube, where I answer your questions live on the air. But you can also hire me as your tutor. I'm available on an hourly basis. Again, you go to scannerschool.com/consulting, and I am there for hire as well. And I will help you out, as I've done with so many other people, and get you up to speed. Whatever that one little piece is that you can't quite grip or understand, that's what the tutoring sessions are for. Okay? So, I said, again, congratulations. You've graduated the crash course, but join us for the webinar. There's a lot more I'll be sharing there, especially with slides and graphics and videos. Okay? It'll be a lot more enjoyable for you there as well. Scannerschool.com/2021. Again, if you're watching us and catching us in the future, after that session, don't worry, we'll redirect you over there. But all the session notes can be found on our website, scannerschool.com/session162. If you've found these sessions helpful, please share them with your Scanner Radio friends. Share them in your Facebook groups, your Twitter feeds, your Instagram, your email newsletters, or your email mailing lists. Okay, I have seen some people out there who have shared a couple of these last podcasts on Radio Reference and on some of the groups, IOs that I'm a member of, and I want to thank you guys for sharing the podcast. It really helps to let more people benefit from what it is that we are teaching on the podcast. So with that, hope to see you all on the webinar. I'm Phil Lichtenberger, and my amateur call sign is W2LE, and this is Scanner School, where we teach you everything to know about the scanner radio hobby. 73, everyone.